Welcome back. We're going through the important step of preparing our data to be used with a pre-trained model. And we learned in the last video that one of the most important steps when using a pre-trained model is that your data is formatted in a similar way to what your pre-trained model, the data that was trained on. And we saw how we can manually construct a transform here by putting together a pipeline. And we learned that the flexibility of manual transforms, manually created transforms, is that they can contain anything we like. We can get as creative as we want here. We can put in data augmentation. We can put in a whole bunch more things if we wanted to. The only real downside of a manually created transform is that if we've transformed our data in a way that is different to our pre-trained model, well, then we might get performance degradations. And so introduced in Torch Vision version 0.13 is a way to automatically create transforms. So creating a transform for Torch Vision.models, and this is going to be auto creation. I'm going to go here. This is why we spent a lot of time making sure we're using Torch Vision version 0.13 plus. As of Torch Vision v0.13 plus, there is now support for automatic transform creation or data transform creation based on the pre-trained model weights you're using. So if we just go import Torch Vision, we'll just make sure one more time that we're using Torch Vision 0.3 plus, and we should be, because we've checked this a few times now. Yeah, there we go. And so I'm going to get rid of a few of these extra tabs. So if I come to the documentation here, this is version 0.12, the older version of the API. It's important to be familiar with this because you might find this somewhere on the internet, but this is where PyTorch is going. So main, this might be not the unstable version by the time you watch this, but this is the new Torch Vision pre-trained weights, multi-weight API. Models and pre-trained weights, that's where I'm at. Initializing pre-trained weights, but here we go. As of v0.13, Torch Vision offers a new multi-weight support API, which is much better than the previous one because you can use different forms of weights. So here we go, we've got a model from Torch Vision models, import ResNet 50 and import ResNet 50 weights. You didn't used to have to do this, but now they've added an extra step, which, yeah, it's an extra step, but adding that extra step has dramatically improved how this API works. So the old weights, so we have V1 here, gets an accuracy of 76%, whereas the new weights, trained in a new way, gets an accuracy of nearly 81%, so a jump of almost 5%. So that's the benefit here. We can use multiple different models, and if a better version of that model, the weights for that model, the patterns that model has learned comes out, well, we can instantiate that with a single variable. So that's what we're going to be focused on here. And if you do see it in the past or in other older tutorials of PyTorch, you might see a model name and then pre-trained equals true. That's the deprecated version, so you will get errors if you write or see code like this from future versions, but we're going to be using, as of recording, the latest cutting edge version. So if we keep going down, using pre-trained models, I'll let you read through that. In fact, this is going to be your extracurriculum, is to read through Torch Vision models and pre-trained weights for 10 to 15 minutes to get an overview of what's going on, but we're going to practice this by writing code. So then if we come down to classification, there's other models here for semantic segmentation, video classification, object detection, all different kinds of pre-trained models depending on your problem. But what are we trying to do? We're trying to classify images of pizza, steak, and sushi, and we have a bunch of different computer vision architectures that we can choose from here, which Torch Vision has so kindly provided pre-trained weights. I'm not going to go through all of these. I'll let you do that on your own. One of the best models that I've found to work is EfficientNet. There's also EfficientNet v2, but beside the point, let's focus on one. So if we jump into this architecture, EfficientNet is from this computer vision paper. EfficientNet, if you'd like to read up how EfficientNet was created, what these do for us is give us access to an EfficientNet B0, B1, B2 architecture. And a general heuristic for looking at computer vision models, or any model in general, is if they have some sort of number associated with them, for example, B0, B1, B2, the higher the number, the bigger the model. That's something you need to take into consideration when you start to deploy your models, is that if your model is too big, yes, you might get the best performance from EfficientNet B7. However, it might not run in your application because it's just such a large file. So to begin with, we're going to start small and scale up when necessary. Let's dive into EfficientNet B0. What do we have here? In fact, EfficientNet B0 is what's running my computer vision app, Nutrify.app. So if you take a photo and upload that, it's running an EfficientNet B0 in the browser. It's my little bias towards EfficientNet. So if we jump in here, what do we have? We have some weights, parameter, torchvision.models, EfficientNet B0, weights. That's what we're going to be looking at. Weights, and we find the EfficientNet B0 weights available from PyTorch have this performance on ImageNet. 77.692, accuracy at 1. So that's predicting on ImageNet with 1,000 classes. It predicts out of 1,000 classes and 1,000,000 images at nearly 78% accuracy. That's pretty good. And the accuracy gets even higher if the predicted class is in the top 5 predictions of the model. So let's focus on using this one. How could we create automatic transforms using this model? And the same process will go from whatever model we'd like to use. If we'd like to use ConvNext or Vision Transformer, this process will be much the same. Let's just focus on EfficientNet B0. If we want to get the automatic transforms, we start by importing the weights. Let's see what that looks like in code. So get a set of pre-trained model weights, and we'll go weights. So this is going to be patterns that a model has learned on ImageNet. And we want to leverage those patterns for our own custom data. So EfficientNet, torchvision.models.EfficientNet B0, and then we're going to go weights. So the model name, and then .default. And so this is another benefit of using the new API. Default equals best available weights. So the best performing weights. Now, of course, if we jump back into here, EfficientNet B0, if we look at this, the model builder above accepts the following values as the weights parameter. .default is equivalent to EfficientNet B0 weights.ImageNet 1K v1. So this means that default is the same as using the ImageNet weights, so ImageNet 1K. So if we import this, that means we're getting an EfficientNet B0 architecture that was trained on ImageNet 1K, so the 1,000 class ImageNet. There's also ImageNet 21K, which is 21,000 classes, which is quite a big model and quite a big amount of data. So let's have a look at what this does. There we go. EfficientNet B0 weights, ImageNet 1K v1, default. Oh, this is so exciting. This is some cutting edge stuff. This is barely even released right now. So let's get the transforms used to create our pre-trained weights. We will go auto transforms equals weights dot, so we've got the weights here. Look how easy it is to create these transforms. Dot transforms. And then auto transforms, let's have a look at what they look like. Wow. Okay, so instead of manually creating this pipeline up here, we've just gone, okay, we would like to use EfficientNet B0, and you could choose whatever model you want here. And then associated with the weights is how those weights were created now. That's the beauty of the updated Torch Vision API. Now, if it's your first time using Torch Vision, this is going to be the standard for you. So congratulations, this is an amazing piece of code. We have crop size 224, which is very similar to what we've done here. Resize. Then we have, well, it resizes to 256. Then it gets the center crop of 224. And then it uses mean and standard deviation to normalize the image, which is the exact same as what we've got here. Except this one is manually created. This one is just giving us this transform automatically. Now, let's create the same data loaders that we did above here with the automatic transforms. So create data loaders using automatic transforms. So train data loader and test data loader, and then class names equals data setup dot create data loaders. Trained is going to be our training directory, and then tester is going to be testing directory. Transform is going to be auto transforms, and then the batch size is going to be equal to 32. Now, is it transform or transform? Let's run that and see what happens. Beautiful. So train data loader, test data loader, class names. We get basically the same thing as what we got above. Well, exact same thing as what we got above. So the things to keep in mind here is that when you're preparing your data to use with a pre-trained model, it's important to consider how that pre-trained model, such as the one in torchvision.models, you'll have to pay attention depending on the source where you're getting the pre-trained model as well. It's important that your custom data is transformed in the same way the data the pre-trained model was trained on. And for Torch Vision in particular, we can create a transform manually. We just have to create a pipeline like this. The benefit of this is that it's infinitely customizable. The downside is that if we put a foot wrong and create the wrong transform, our model's performance may be degraded. And as of Torch Vision version 0.13 plus, there is now an automatic way to create transforms when you use a pre-trained model, and that is by leveraging the weights from that pre-trained model. So say we wanted to use EfficientNet B0, but this would be replicated basically with whatever pre-trained model you want. So if you go into here, there's classification, whole bunch of different models here. And then if we scroll down, we have table of all available classification weights. So we have weight and then a whole bunch of different models here. We'll go through that in the next video actually. And then you can call .transforms on those pre-trained weights. And you can use those transforms when creating your data loaders, just the same as we used a manual transform up here. So as I said, the extra curriculum for this is to read through this documentation, models and pre-trained weights. Make sure you're on a version that's using v0.13 plus. And if you want to look at the old style of doing things, you can look at v.12. At the time of recording, that is the stable release, but we're focused on the latest and greatest here. I'll see you in the next video. Let's discuss how to choose a different model.